This is the final installment of the dustpan collaboration I'm doing with this old Tony. As soon as I finish the sheet metal pan, the finishing touch will be mounting Tony's one-of-a-kind handle. This series has been my most popular ever on YouTube. Nearly all the comments have been positive, but a few people have questioned why I would spend so much time on a dustpan. At the end of this video, I'll show you a real-world application of the technique shown here. In the last video, I shaped the piece that will be the back wall and the two sides of the dustpan. And the first step to move forward is I want to make an angled cut on both sides so this can intersect with the base of the dustpan. And I'll show you a good way to lay out that angled cut. I've made a holder for this sheet metal piece, so the front of this gets held with screws. And I made small clamps that hold the back edge down tight. So this fixture holds the sheet metal part rigidly. And now I'll use a marking tool to lay out the cut. This is my marking tool. As simple as it is, it actually has a good degree of adjustability. All I need to do is to tap this down to lower it, or I can tap it the other way to raise it. And I can dial it in very precisely. And now I can use this tool to mark around the edge. I'm going to do this in two stages. I need to remove some of the waste so my fixture can come down to contact the table. And then I'll mark my final cut. So I'll use aircraft shears to cut on that line. So now this can go back in the fixture to mark the final cut. Now I can trim on this line, and I'll be certain that I've established a surface that's absolutely flat. I'm going to make a hammer form to help me curl the bottom edge of this, and also to make the base for the dustpan. So I've glued together two pieces of 3/4 inch MDF, and I'm going to mark this for trimming. So I've drawn a line 1 1/4 inch away from the front edge of the hammer form. I'll use some drywall screws to temporarily hold this aluminum piece into place. Then I'll use a pencil to mark the inner edge of the aluminum part right against the hammer form. So now I can trim on this line. I've sanded this edge smooth, and I've been careful to get a very nice fit against the metal part. So the next step is to round over the edge of the hammer form. Now I'll use the same hammer form to round over the edge of this part and to round over the base as well. And it's time to decide what kind of a radius I want to use on this. This is a piece of 2-inch diameter round stock. And this has about the radius that I want, so it's a 1-inch radius from the center to the edge. So my plan is to put a 1-inch radius on the back, and then it will taper as it comes out to the sides. So now I'll show you the process I use to make the radius edge that tapers toward the front. Here's how I'll do the layout for the rounded edge. I'll draw two lines at a right angle, representing the square corner of my form. For better accuracy, I'm working at 4 times actual size. I've cut an 8-inch diameter disc, which has a radius 4 times the size I want on my hammer form. I'll place the disc so it's tangent to the lines and draw an arc. This represents the rounded edge. Next, I'll draw a line at a 45-degree angle, tangent to the curve, showing the first chamfer I'll make on the corner. What I'm looking for is the distance between the corner and the edge of the chamfer. I'm reading 2.5 inches, which translates to 5/8 inch actual size. So the first step will be sanding a chamfer that touches lines drawn 5/8 inch from the corner. Once the chamfer is made, I'll create 2 smaller chamfers on each side. I've set a protractor to 22.5 degrees, which I'll use to make another line tangent to the arc. Measuring from the corner of the first chamfer to the edge of this smaller chamfer, I'm reading 3/4 inch, which translates to 3/16 inch actual size. I'll sand a second chamfer on each edge of the first chamfer, and once I've done that, you'll see that I have a surface very close to a true radius, which will smooth out with a minimum of sanding. It's time to lay out the lines I'll sand to on the hammer form. So this first line is going to be 5/8 of an inch away from the edge. Then I'll use a compass to actually draw that line. And I've made marks that show where I want the taper to start and to end. So I'll start marking here and go all the way across to the other mark. And then in the tapered area, I simply need a straight line. So I'll use a straight edge to connect the 2 points. I'll do that on both sides. Now I'll rotate the part to mark the other side. Using the same compass setting, I'll mark the other edge in the same way. And for the tapered section, I'll use a straight edge. And I'll do the same on the other side. So now I'm ready to sand a chamfer on this edge. Okay, I'll rotate the part now and sand the other edge. And now we'll sand the last edge. Now I'm ready to do the layout for sanding the next 2 bevels. So I'm using a pencil to darken up the line. And next I'll be measuring out 3/16 of an inch from these lines. And a convenient way to measure 3/16 is with masking tape. So this is 3/16 tape, and I'll simply lay it down so it touches that pencil line. And I'll lay down a second row. Again, I'm just bringing the tape right up to that pencil line. Now I don't want to sand on the tape because the sanding could peel the tape off. So I'm going to make a pencil line right on the edge of the tape. And when I sand, I'll sand up to the pencil line. Okay, now I can peel the tape off. And in the straight sections, I can use the straight edge to continue the line to the point. So now I'll sand a chamfer that touches these 2 lines. I'll do the same thing on the other edge. I'll use the 3/16 tape to move that line over. And I'll use a pencil to give me the line to actually sand to. And now I'll use the straight edge to bring these lines to the point. And now I'll use the disc sander to sand right down to those lines. So I have 3 chamfers on the part now, and if I've done everything right, the distance between the chamfers should be equal. So all we have to do at this point is just sand the corners off of these peaks. So that's the best way I know to achieve a beautifully rounded edge, both on a curve and on a taper. It's a pretty powerful technique. Now that the hammer form is shaped, I need to make a couple of patterns. The first is for the clamping block, and the function of the clamping block is to hold the flat metal flat. So I know that this is a 1-inch radius, so I know that the radius ends 1 inch from the edge. I've cut a piece of chipboard the same size as the hammer form, and to make the pattern for the clamping block, all I need to do is to measure in 1 inch from the edge, make a mark, then I'll set my compass so it can mark a line exactly 1 inch from the edge, and I'll mark a line all the way from the point where the taper starts on one side to the same point on the other side. And then for the straight sections, I just need to draw a straight line that connects this point to this point, and do something similar on the other side. So if I cut on these lines, I will have the pattern for the clamping block. I also need to make a pattern for the piece of metal that gets formed over the clamping block, and that's a little more tricky. I know that I want this metal to curve down until it has a 45-degree angle on it. So if I take something that has a 45-degree angle on it, the point where that 45-degree angle touches the form is exactly where I want the edge of the metal to be after it's formed. So an easy way to figure that out is to take a piece of masking tape, and I folded one down over so the sticky side is stuck to the sticky side. Then I'll hold this on that mark I just made and lay the tape down. Now when this springs out, this shows me where the edge of the blank needs to be. So if I take a vertical surface and hold it against the edge of the hammer form and measure the distance between the form and the tape, that tells me how much undersize my blank of metal needs to be, and it's exactly 1/4 inch. So that means that the pattern for the blank of metal needs to be 1/4 inch in from this edge. So let me put a mark on the paper, 1/4 inch from the edge. I'll set the compass to trace that distance, and I'll make a mark all the way from the line on one side to the line on the other. And again, the straight section just needs a line drawn from this point to the place where the taper ends. I'll do the same on the other side. So this is how I'll make the pattern for the clamping block and for the blank of metal that will be shaped over the hammer form. So using the paper pattern, I've cut a blank of metal, and you'll notice I put holes for alignment pins in the form itself and in the metal. And using the other pattern, I've made the clamping block. So let's get this all assembled. There's no need to anneal this part, and in fact annealing would leave it too soft and probably disturb the flatness. Now I'll start tapping the metal down against the hammer form, and I'll use a low crown hammer to start this. You can see the majority of this is laying down very nicely. I'm going to use a caulking tool that will allow me to focus my hammering force into a smaller area. And I'll start working on this side now. Okay, that's looking great. I'll pull this apart so you can have a close look. So there's our hammer formed part. And as you can see, the edge radius is very, very uniform, and I was able to keep the center part of this absolutely dead flat. So that's the beauty of the hammer form. It doesn't take a lot of skill to push metal over a hammer form with a hammer, so all of the effort goes into making the form, but once that's dialed in, the parts come off it straight and true. Now we're going to use the same hammer form to curl the edge of the other part. So the first thing I want to do is to put the part we already formed in place, and I want to make a mark that shows exactly how far down this curled edge comes. So the next part we're going to make will meet that edge. I've modified the hammer form in a couple of ways. Number one, I put a spacer on here that lifts this up so that when the part we're forming is put in place, this is at the same level as that line. So when I form this over by hammering, it will touch that line. And the other thing I did was to put a backing strip on this, allowing me to use clamps to pull this back as I do the forming. So I'll put this in place. I'll use a couple of small clamps to hold the front edge down, and then I'll use some larger spring clamps to help pull this back to keep it tight against the form as I do the hammering. So now I can hammer this part against the form. Okay, so the forming is done. I will take all the clamps off, and you can see what a beautiful job the hammer form did of shaping this part. So now you can get a sense of just how well these parts actually fit together. So we're just about ready to tack weld these. I put a center line on the hammer form, and using that center line, I made a mark right in the center of both the upper part and also the lower part. And these center marks will help me align the pieces when I join them together. I want to put a step like this onto the front edge of the dustpan for two reasons. One is that it will strengthen the edge, and also it provides a little shelf so the dust can't easily tumble out of the pan. So I'm going to cut this panel on the line, then I'll use a beading machine to roll this step into the leading edge. I put a set of step dies on my beading machine, and I'll do this step in 3 passes. I'm going to start with a very shallow pass. Then I'll go a little bit deeper. And this will be the finish pass. So you can see what a great job those dies do of making that step on the front edge of the dustpan. It's time to tack weld these parts together now. So I have everything jigged up so the alignment is just right. And let's put a couple of small tack welds into place. I contaminated my electrode, so I'll have to put a fresh one in here. So the first tacks are in place. I'm going to make the rest of the tacks from the other side. With the parts tacked together, I can remove this piece of wood. Everything's coming along nicely. I'm going to work on the alignment of the front corners next. A great way to get the alignment I need is to pull the parts together with a C-clamp, and then when they're tightly together I can tack weld them, and that should hold them in place pretty well. I'm going to fill this hole also. And now I can weld this seam. And I'll treat the other end the same way. I'm just about ready to make the finish weld, and there's a couple of last steps before I do. I want to tap these edges together to make sure I have the best fit possible. I also want to wire brush this surface to make sure it's perfectly clean. And now I'm ready for the finish weld. I'm trying out a Pyrex cup on my TIG torch, and it certainly lights everything up better. Thanks to Jody at Welding Tips and Tricks for this great idea. I'm going to make a second pass on the inside, fusing the joint together. I should need to add filler rod for this. I'm going to use a disc sander with a foam pad to sand the weld in this inside corner. I'll put a little lubricant on the metal first. So I'm very, very happy with how that's cleaning up. Now we'll get the corner weld smoothed down. The best way I found to get a nice finish on this is to use a 2-inch diameter nylon abrasive cup wheel. Now I can cut the outside of the weld down smooth, and I'll start with a 50 grit disc. So I'll switch to 120 grit now to smooth it down some more. And I'll switch the sander to orbital mode to get the final finish. You can see how quickly the weld cleans up, and a large part of that is because I formed the metal quite accurately before I made the weld. I decided to put a little finer finish on this, so I'm going to use 320 sandpaper on an orbital sander. And then I'll use the Scotch-Brite pad to blend everything together. So the dustpan is completed, and I think the time and effort was well worth it. Now I just have to wait for the handle to come in. You know what? I think I hear Tony's drone coming in right now. I can't wait to have a look at this. Oh my gosh, that is absolutely exquisite. Look at that beautiful blending of wood and metal. And this grip fits my hand perfectly. This small notch is perfect for my index finger, and the large scallop is great for my fingers to fit into. It didn't take me long to put the handle on the pan, and I think they complement each other perfectly. And as I promised, I'll show you a real-world use for these layout and fabrication techniques. Several years ago, I updated the dashboard on a vintage truck. The center of the dash had to be reconstructed, and as you can see, the shape in the corners is much like the dustpan. Pay attention to all the layout and fabrication techniques you see. You never know when they may come in handy. Hats off to Tony for suggesting this collaboration. His handle design is exquisite, and he's been a great guy to work with.